Hello, my amazing students. This is Mrs. A, and we are starting 3.5 because you're going to have a test on 3.5 next week, and I'm trying to get these videos out so in time for them to do you some good. So here we have the absolute value of 5x is equal to 4. This whole chapter is on equations and inequalities with absolute values. And it is pouring outside, and I am wet from head to toe. So my hair's a little wet, everything's a little bit wet, but I'm going to get this video done. So here we go. When we think about absolute value, we want to always think two cases, all right? Now, I showed you we can write this as two equations. So we could say, all right, 5x either already was positive, which means it already is 4, or 5x started as a negative 4 and the absolute value sign made it positive. So this statement is equivalent to two statements, and it's either or. We don't know which one, but we want to find every single solution, so we set them both equal to 4 and negative 4. So when we solve this one, we get x is 4/5. And when we solve this one, we get x is negative 4/5. And those indeed are the two solutions. Now, I showed you in class a mathematically incorrect but much faster way to do it. And it's the way that I do my absolute values. So I'm going to show it to you, recognizing the fact that it's just a shortcut for writing out the two equations. Okay, so what I do is I take the absolute value of 5x is equal to 4, and when I erase the absolute value sign, I realize that 5x must be 4 or negative 4. Now, I understand when I do that 4 does not equal negative 4, and but that 5x could be equal to either 4 or negative 4. So since I'm trying to find them both, this is just a shortcut for doing this. It is mathematically not correct because negative 4 does not equal 4, but it works, it's fast, and as long as you realize that it's just a shortcut, that it's not really equal to 4 is not equal to negative 4, then you're pretty good. Okay, so then I would divide by 5 in all three parts here, and then I get my x by itself, and I get my 4/5 on one side, and I get my negative 4/5 on the other. So it's just a shortcut for getting the same two solutions that we had before. So there's a close-up of your board, and this was problem number 10 on 3.5. Okay, so problem number 20 on 3.5. Okay, and again, I can write this as two equations. I can say 1/3 x minus 4 equals 13, or 1/3 x minus 4 equals negative 13. Since I want to solve them both, I want every solution, I'm going to solve both of them. Both of them are going to give me solutions. I'm going to do this my little quick way, and I'm going to say 1/3 x minus 4 is equal to 13, but then I'm going to take off the absolute value sign, and I'm going to say, or negative 13, because it was negative. If it was negative before the absolute value came along, then it would be a positive 13 afterwards. So on this one, we have a little bit more to do, don't we? We're going to have to, since we're trying to get x by itself here, we're going to add a 4 to all three parts here. So we're going to add a 4, and add a 4, and add a 4. Okay, so now I come up with over here a negative 9. Okay, so I'm going to go ahead and erase one of these because I'm running out of time. I'm going to erase both of those because this one is taking care of both situations. So I'm going to wind up with a negative 9 is equal to a 1/3 x, and then my 4's are going to cancel, and on the other side I get a positive 17. Okay, so now all I have to do to get rid of my 1/3 is multiply all three parts by 3. So I'm going to multiply this by 3 and get a negative 27. I'm going to multiply this one by 3 and get an x. I'm going to multiply the last one by 3 and get a 51. And so x is equal to negative 27 or 51. Those are my two solutions to the problem. Negative 27 and 51 are my two solutions. That is number 20 on section 3.5. And now we're going to do number 30. I'm trying to jump through by tens and give you some examples. So on this one, don't I need to subtract a 9 from both sides? So when I subtract a 9 and subtract a 9, it would almost seem like I'm going to be in trouble because I'm going to get a negative 2 over here, but I've got the absolute value also has a negative sign in front of it. So this goes out and I'm left with something that I can still do. Remember, an absolute value can't be equal to a negative number. But since I have a negative absolute value, it should work. So basically, if I multiply both sides by a negative 1 right now, then I get the absolute value of x minus 2 is 2. Okay, so I've simplified it down. I always have to simplify it all the way down until I get my absolute value by itself, and then I can do the 2 and negative 2. So we take off the absolute value, equals 2, equals negative 2. Again, remembering that's not mathematically correct. I should write it as two separate statements, but I'm a little bit lazy sometimes. So this works. We're going to add a 2 to get the x by itself, add a 2, add a 2. So whatever I do to one part, I do to the other. And then this one becomes a 0 as one solution because my x is now by itself. And on the other side, I get a 4 as my other solution. Now, I have not been going back on the other problems, but I'm going to go back on this one. All of them should work. So I'm going to test. I'm going to check. If I go back into my original equation and I plug in a 0, 0 take away 2 is a negative 2, but the absolute value of a negative 2 is a positive 2, and 9 minus 2 equals 7. Okay? If I plug in the 4, then I get a 4 take away 2 is a 2. And the absolute value of a 2 is a 2, and 9 minus 2 is 7. So both of these are going to work for you. There is number 30 on 3.5. Okay, so now we're on problem 40, but I'm going to do 40 in two pieces with two options. Okay, so number 40 is actually absolute value of x is greater than or equal to 2. But we're going to use this opportunity to talk about what happens when it's less than or equal to 2 also, since it's a very simple one. All right, so if I were to just take the absolute value of this and stick it in between 2 and negative 2, hold on a second, my marker won't open. There we go. All right, so basically what's happening is that we're saying on the number line, let's look at this thing on the number line. So if I let x be 0, then 0 would be less than 2. Okay, so 0 is a solution. If I let x be 1, then x would be less than or equal to 2. So 1 is a solution. Okay, anything in between 0 and 1 is a solution. If I let x be 2, then isn't 2 less than or equal to 2? Because of the equal sign, that would also be a solution. Okay, well, what happens on the negative side? Okay, if I try for negative 1 and I plug in negative 1, but then the negative 1 makes it positive, then positive 1 would also be less than or equal to 2, wouldn't it? So this goes here. This is part of the solution. And then negative 2 is also going to work because negative 2 will become a positive 2, and 2 is less than or equal to 2. Okay, now see what happens as soon, so all of this in here, from 2 to negative 2, makes that inequality true. Okay, so then what happens if I go to 3? If I plug in a 3, then all of a sudden, 3 is not less than 2. Okay, if I plug in a negative 3, and all of a sudden, negative 3 becomes a positive 3 Positive 3 is not less than or equal to 2. So my solution ends here at negative 2 and 2. Isn't that what you would get if you just thought of this as an equal? Wouldn't the two values that you would put on either side be 2 and negative 2? They would. Okay, so basically we can do an inequality just the same way that we can do an equality. We get the absolute value all by itself, and then at that point we can say x must be less than or equal to 2 but greater than or equal to negative 2, and that is the solution. All right, so we kind of observed what was happening, but anytime you have a less than, the inequality is going to be in between your two values that you would have had if it was an equal sign. Okay, so let's look at the same thing, but now we're talking about a greater than sign instead. Okay, so now, again, when I took off the absolute value sign, it would be a 2 and a negative 2. So let's keep that in mind, 2 and negative 2. And let's kind of go through our analysis again on our number line and see where we have solutions. Okay, well, because of the greater than or equal sign, if I have a 2, it is going to be equal to a 2. And if I have a negative 2, it is going to be equal to a 2, isn't it? So these two are in the solution set. Now, if I pick 0 on this one, then I say 0 is greater than 2. That doesn't work. Okay? In fact, anything in here, inside, in between, none of this is going to work. Okay? Every single value in here is going to be less than the 2. So what we're going to do is we're going to try a 3 out here. We plug in a 3. 3 is greater than 2. That works. We plug in a 4. 4 is greater than 2. That works. In fact, any number that we plug in to the right of 2 is going to be a solution. So our solution goes off to positive infinity in that direction. Well, if I plug in a negative 3, the negative 3 maps over and becomes the same thing as the 3, and it works. Negative 4 maps over, becomes positive, becomes the same thing as the 4, and works. So now I'm going to have my solutions going off in two directions on the number line. So anytime you have a greater than, you're going to go off in two directions. Okay, so now let's do number 50. And 50 is x minus 0.5 is less than or equal to 0.2. Now I already have my absolute value all by itself. It is a less than, and so what I'm going to do is I'm going to pull it out, and I'm going to say on the right I've got a 0.2, and on the left I've got a negative 0.2, and I've got a less than or equal to and a less than or equal to, and now I take this out of the absolute value sign. So that is my initial equation. And now I'm going to get rid of the negative 0.5 to get my x by itself. So we're going to add a 0.5, and we're going to add a 0.5, and we're going to add a 0.5 to each part. And then this one is going to give us a 0.3, okay, and then is less than or equal to x is less than or equal to a 0.7, okay. So graphing this, remember inequalities we should graph. So here's my 0, okay, and here we'll say 0.3 is right here, and 0.7 is right here, and 1 is right here, okay. So we're going to say that this one is going to be right in between, including the endpoints here, here, and going in between. So it has a very tiny graph in between 0.3 and 0.7. Now, can we check absolute values? We can, okay? Now, these two endpoints should make the equal situation true. So if I plug in a 0.3, then I'm going to get a 0.3 take away a 0.5, which is going to be a negative 0.2, and then the absolute value makes it a positive 0.2. If I plug in my 0.7, I'm going to get 0.7 take away 0.5 is a 0.2. The absolute value of a 0.2 is a 0.2. So the endpoints of your answer will be the equal answers up here, okay? And then you can certainly see if your sign is facing the correct direction by just taking any number that is outside this region. It should not work. Any number inside that region, you should be able to plunk down a 0.5 because 0.5 is in between 0.3 and 0.7. So if I plugged in a 0.5, then I get a 0.5 take away 0.5 is a 0, and a 0 is less than a 0.2, so it works. Anytime I can check a 0, I will check a 0 because zeros are easy to check. And that is your board for problem number 50. All right, so now we're going to go to problem number 60. All right, so problem number 60 is a greater than. So when we think of a greater than, we're going to think it's going to go on both ends. It's not going to be in the middle like a less than is. All right, so I'm going to go ahead and write this as two equations because this is going to be going in two different directions. So I'm going to say 2x minus 1 over 3, if it was already positive, is going to be greater than or equal to 5 over 6. Okay, and then 2x minus 1 over 3. If it's negative, it's going to be less than negative 5, 6 because it's going to have to map over to be greater than. So it's going to be less than or equal to a negative 5, 6. So again, I'm using just the positive and negative of those numbers and writing my two inequalities. So since this is a or situation, I'm going to wind up with two different graphs on the same line. I graph them together, but they're two going off in two different directions. I make two equations. Okay, so now can I multiply through everything by 6 and just clear out those fractions altogether? So let's do that. Let's multiply this by 6. Let's multiply this by 6. Okay, and we're going to wind up with the 6 and the 3 canceling. So I'm going to end up with a 4x minus 2. 4x minus 2 is greater than or equal to 5. Okay, so then when I plug in, I add a 2 and I add a 2, then I'm going to get 4x is greater than or equal to 7. And then I'm going to get x is greater than or equal to 7/4. Okay, so we're going to write that as one of our answers. So we're going to write it. Let me see where I can write it. I think we're going to have to get another board. So we're going to write that as x is greater than or equal to 7. Okay, so we wrote down 7/4. Okay, so this was the first part of the problem. And now we've got to come back and do this one, right? We haven't done this one yet. But we have done the rest of it, and we've gotten x is greater than or equal to 7/4, which we have right here. Okay, so I'm going to write the second option, the second case, 2x minus 1 over 3 is less than or equal to negative 5, 6 from the other board. So I just copied it. And so now we're going to write this option. Now remember, when we're doing a greater than, it's always going to be an or in between the two solutions. So when we finish this solution, we'll put it up there and then we'll erase and graph them. All right, so this one, I'm going to multiply through by 6 again to get rid of all those fractions. Fractions just make things messy. Now remember, I don't have to flip the sign because I multiplied by a positive 6, not a negative 6. All right, so this one becomes a 2, and I'm going to get a 4x minus 2, and then less than or equal to a negative 5. Okay, so then I'm going to add the 2 to get rid of it. So now I have a 4x is less than or equal to a negative 3. Okay, and then when I plug in divide by 4, I'm going to get x is less than or equal to a negative 3/4. Okay, so there's your second board. And I'm going to leave this one here for a minute and go get another board. So now what we're going to do is we're going to graph and then check both of our answers. Okay, so our answers are x is greater than or equal to 7/4, or x is less than or equal to -3/4. All right, and my original problem, I'm just going to write it, well, we'll pull it up because I still have it. So there we go. Those are our solutions. Now, our original problem, we're going to check in here. First of all, let's graph these. Okay, so x is greater than or equal to 7/4. So here's my 0. And then we're going to go 1, 2, 3, 4. 7/4 is a little bit over 1, right? So we're going to put 7/4 right there. 7/4. Okay, and then -3/4. Here's my 1, so -3/4 is right there. And x is greater than 7/4, so it's going to go that way. And x is less than or equal to -3/4, so it's going to go off that direction. So it is a split graph. It's going left, it's going right, nothing's in the middle. So now we're going to check it. Now remember that the absolute value of 2x minus 1 over 3 is greater than or equal to 5/6. That was my original equation, inequality. So now remember what I said, that these endpoints should each make this equal. So let's plug them in and see if we have them. So 7/4, let's check 7/4 first. So when I take 2 times 7/4, I get 7/2, which is 3.5. And I take away a 1, which is 2.5. And so I end up with 2.5 over 3 is, so let's write that, 2.5 over 3. And then we're pretending this is equal because we're checking is equal to 5/6. Well, if I multiply 2.5 times 2 and I multiply 3 times 2, I do get 5/6. So that is equivalent. So this one checks as being part of the solution. And then my -3/4, I'm going to plug it in. Okay, so when I plug in -3/4, I multiply by 2, I get -3/2, which is -1.5. Take away another 1 is -2.5 over 3. But then when I take the absolute value, don't I get 2.5 over 3 again? And it works. So those are the correct endpoints. Now, to make sure that I have graphed the correct way, I can pick a point over here, an easy point, and pick an easy point over there to make sure it's true. I could also pick 0. And since 0 is not in the desired region, 0 should not work into the problem. And that would be a good indication that I had done it correctly too. So if I plug in a 0, I get a -1 over 3. Absolute value is +1 over 3. Greater than or equal to 5 over 3. I'm over 6. Well, 1 over 3 is the same thing as 2 over 6. And 2 over 6 is not greater than 5 over 6. So 0 doesn't work and 0 shouldn't work. So we have graphed it correctly. That was number 60. And just so that you have them one more time, I'm going to show you the 3 boards. They're a little bit messy, but that was the first board where we started and we worked the first part. And then this is the second board. And the third board. Okay, so now we're going to do a few that are what are called special cases, where we either have no solution or whether we have all real numbers are the solution. So I'm going to get those on the board and be right back. So this is pretty easy. All right, so I have 2 problems, and both of these problems have no solution. Can you see why? All right, if I have the absolute value is less than 0, that means I have a negative number, and the absolute value cannot be a negative number. Now, I can have an absolute value equal to 0, and when I have an equal to 0, it just means that 3x plus 5 must be equal to 0. All right, but that one has no solution. Then this one has an absolute value that is less than a -4. Well, absolute values have to be positive, and nothing that's positive is less than -4. Therefore, that one has no solution either. So this is an example of 2 no solution problems. All right, so and these are 2 examples of problems that have all real number solutions. Every number on the number line is going to make these true. If I have an absolute value greater than or equal to a negative number, okay, so the greater than it's never going to be equal. But since it says greater than or equal, it is all real numbers because all absolute values will be greater than -4. So it's a done deal. Nothing needs to be done. You just say, oh, all real numbers would work in there. This one is also greater than a negative. And since it's greater than a negative, it's going to be all real number solutions because all absolute values will be 0 or positive. And so we don't even have to do any work with those. It's just an interpretation. And we are done with 3.5. That was a pretty quick section. And I will be coming back to you with 4.1 shortly. And this is Mrs. A. And may God bless your day.